area, not perimeter anymore, area, okay? Rectangles and parallelograms. I'm not sure why they had to put and there because, as you know, rectangles are parallelograms, aren't they? Before right angles, okay? So the area of a rectangle, hopefully you know this, is length times width, right? It doesn't really matter which one you call the length and width, but like if you really had to know the length of a rectangle would be the longer, and the width is usually the shorter. It really doesn't matter, okay? You could also think it's probably more useful to think of it as base and height instead of length and width, okay? So the base of a rectangle is just one side, and the height is just some other side perpendicular to it. That's the key, perpendicular, okay? So whenever you're doing area and you need base and height, and this goes for triangles and rectangles, anything else, right? You need, this is important, base and height must always be perpendicular to one another to be a valid base and height.
Why is that not?
What?
Why not? Well, if they weren't perpendicular, then it wouldn't be a rectangle.
Right, so the handy part about rectangle is all the sides are perpendicular, right? So we got that, right? But if we go to just a regular parallelogram, we got to tweak things a little bit, okay? So, here's a rectangle, and this is a, you know, an area, it's just like counting up all the stuff within it, right? But instead of counting, we can multiply 6 times 2 in this case and get 8 square units or whatever it is, okay? You know how to do that, okay? So the area of a rectangle, we'll use the base times height, right? That's more handy to use than length and width, okay? And again, a rectangle, the consecutive sides are perpendicular already, so we got base and height built in perpendicularly, right? Now, for just a regular old parallelogram, it's not necessarily a rectangle, it's a little bit different, right? The area of this parallelogram, would it be D times C? It would not. Why not? Okay? Because we must have base perpendicular to height. Okay? We don't have that here. So maybe they'll give us something, or you'll have to draw it in and work it out. Something like that for the height of the parallelogram. Right? Then you have a base and a height that are perpendicular, you get the area. You with me? So it's not different than a rectangle, it's still base times height. Okay? But you got to make sure base and height are perpendicular. All right, so let's go to the next page. We're going to look at the area for a parallelogram now from the aspect of some transformation. Okay? Transformation here. So take a look at this parallelogram. They drew in a height, which makes a little triangle off to the side here, right? Okay? We could take this triangle that's delineated by that height that was drawn in and slide it or translate it over to this end, right? Take it from one side, put it onto the other. What does that shape then become when we do that? A rectangle. And by the way, translations are what?
Isometric.
Are isometric. So this will be a rectangle with the exact same area as the parallelogram it came from, because we just translated, right? Okay, so that gives us a rectangle, and now base and height are perpendicular. Think of it as doing a transformation on one end of it there, okay? So just like a rectangle, the area of a parallelogram is still base times height, but we need to make sure, because if it's not a rectangle, right, there's nothing necessarily perpendicular, that we have base and height perpendicular. It's got to be, okay? And by the way, area of a parallelogram also includes what shapes? Yeah, rectangles, rhombus, squares, right? Okay, so it includes rectangle, rhombus, square. Okay? So that area of parallelogram formula applies to all those things in your flow chart because they're all what? Parallelograms, right? Here's an example. And notice they add this here. Okay? This is the one time you've been able to, hey, it looks perpendicular, so it is, right? Because they set it. So the area of this thing, it's a rectangle, so it'll be what times what? 2 times 5, so area is what? 10 square centimeters, okay? Now, for the next one, it's not going to be 12 times 15, why not? Okay? There's a couple of ways we can do this. What kind of triangle is this here? It's a 30, 60, 90 right triangle, okay? And, well, now be careful here. What would be the short leg? How do you know it's the dotted line? It's kind of unclear here the way they drew it.
The right
Well, I don't know. Yeah.
short side.
Listen, you remember we talked about this. The shortest side would be across from which angle? The smallest angle, right? So the short side here is that. That's our height that we need. The 12 is the what of that triangle? Hypotenuse. How do I go from the hypotenuse, right, to the short side? So the height of this is what?
6.
All right, you got that? We got to remember special right triangles, okay? You could have used trigonometry, right? Done, you know, sine of 30 equals h over 12, multiply both sides by 12, right? And probably you can guess the sine of 30 is 1/2 after 12 is 6, so we're worked out, okay? So we got that then. So the area equals 15 times what? Which is what? 90 centimeters squared. Okay? That's something else written down there. Yeah, I did it where you could just do the sine. You could also do sine. Okay? All right, the next one. We need this perpendicular height. This should be pretty simple. What is it? 3, 4, 5, isn't it? So what's height? 4. Now let's be careful. This is what?
4 times 50,
15. Okay? And if you had to do the Pythagorean theorem, it would all come out, right? So we get area 15 times 4 was 60 square centimeters. Darn it. All right, last one's a little odd. This is one we might have to break up. We do a couple of shapes. So this rectilinear figure, we get, maybe I'll do this. Do that. Make it look more like a dotted line if I can. Maybe I'll break it up into 2 rectangles like this and then add the areas together, right? So that's 10, that's 2, what's this? 2 down here because the congruent marks. So this one is 10 times 2, which is what? Okay, now it's not 7.5 anymore. What's the height of this? Yeah, there you go. So our area will be, well, I'll just put a 10 times 2 plus 5.5 times 2, which equals what? I think it's 31.
I was doing something.
Oh, that is 11. Yeah, right. Okay? Not too complicated, right? The trick is base and height have to be what? And you've discovered that there's different ways to find the heights in these, right? You got to do special right triangles, trig, Pythagorean theorems, triples, whatever, okay? All those tools we need. So let's have you guys take a look at these 4 here. Find their areas. Make sure we know what we're doing. And again, look what they say. This makes it convenient. Without them saying that, you can't assume that, right? But now you can. So go ahead and take a crack at them. Let's get 1 out of the way. What'd you get for 1?
80 centimeters.
80. Base and height are already perpendicular, aren't they? There's that. Perpendicular. It doesn't quite, right? It's okay. So it'll be just 8 times 10, which which equals 80 square centimeters. How about number 2? What you got?
55.
55. There's a couple ways you can do it, right? I treat it as a special right triangle, call that H. So what do I do to the hypotenuse?
Divide by square root of 2.
Yeah, so it's 5 square root of 2 divided by the square root of 2, which gives you 5. And if you did it with sine, you'd still got 5, if you close your parentheses, right? And then, so that's the height, so the area equals 11 times 5, which is 55 square centimeters. And some of you might have broken this one up differently. Everybody get number 3 yet?
84
84
centimeters.
centimeters.
Okay, I'll show you how I break it up, and then maybe you did it differently, got the same thing. I did this.
I didn't.
So you just,
That's what I did a little.
yeah, so you could do it a bunch of different ways. You know, if you do it correctly, it shouldn't matter, right? So that's 6 and that's 6, right? And now, so that's 6, whole thing. What's this one? What's this? 6, right? So our area is going to be that one plus that one, right? 6 times 8 plus 6 times 6. Turned out to be a square, huh? Or something. Yeah, nobody knows what 6 times 6 is yet. Mathematicians have been struggling with that for centuries. 48 plus 36 is what?
84 centimeters.
84 square centimeters. All right. The last one, 5 times 13.
Yeah,
Schnikes no.
I got 6.
Well, we need like that side. What's that side? Because what? Pythagorean theorem, or it's a what? And remember, you got to, if you're going to do a triple, show this work, okay? 5, 12, 13, right? So it's a 12. Whoops. Messed that up. So 5, 12, 13. Come on, circle. There we go, 12. So our area is just simply 5 times 12, which is what? 60 or something. It's not really important, I guess. Okay? Hey, by the way, what would be the area of that triangle?
30.
Half of that. Remember the formula for the area of a triangle? What is it?
Half base.
Half base times height. That's why triangle areas are half, because they're always half some rectangle. Okay? All right. Yes. Let's go to the Regents questions. Look at number 1. Slightly interesting. So, about that.
Wait, these are convert inches in feet now?
Zoom.
No.
Well,
There's inches there.
I know.
yeah, we always want to take a look at the units they give us. That is correct. Yes.
5 by 12.
And so you're going to break this up in some way.
Wait,
Okay? I'll give you a minute.
This is looking like, all right.
So you got just, you always want to look at these. Everything here is in feet. He's doing that, except these guys.
Okay.
So 18 inches, I'm going to write that as 18. You can divide by 12 to get feet, right? I'm just going to leave it as 18/12 feet. And this would be 21/12 feet. I'll leave it like that.
I got the answer.
Well, hang on there.
You know,
Peter McBeater.
yeah.
And I'm going to split mine up like this.
I got it.
Okay.
I got the.
So Olivia, what'd you get?
4.
19.3. What'd you get, Trenton?
I got 2.
And we got 19 square feet. Okay. So I'm just going to say, so my, you had to subtract it, right? Subtract the sink, right? So I would just, generally, the total area, total, so let me number, so I'm going to call like this top section area 1. I'll call this area 2, like that. And I'll call this area 3, or area of the sink. Sometimes that helps, you got a bunch of different things, right? So the total area would be what? Area 1, what? Plus area 2, then what? Minus my area 3, right?
Yeah, correct.
You don't have to do that, I'm just showing you the way to organize your thoughts about things, and things get more complicated, right? So our total area, well, let's see, let's get that. That's not 5 anymore. What's this?
3.
3, okay? So area 1 is what times what? 8 times what now? 8 times 2, plus our area 2, which is what times what? 2 times 3, minus the sink. So 18 twelfths times 21 twelfths, right? And you put that on your calculator. I think it was 19.375 or something like that.
I sold it by hand.
Yeah,
Okay,
That's correct.
so 19. Hey, I think we've seen this one before.
Uh,
I don't think we have to do it. We have 3 ways to solve this now, don't we?
Yeah.
And I put it in here specifically to talk about that. We can kind of connect all the things we've learned, right? Could we solve it using a Pythagorean theorem?
You don't have the exercise though. That's why
It's an easy exercise.
X squared plus x squared equals 58. Right? No, it's not x to the fourth.
So it's a 45, 45, 90.
I'm thinking of x squared times x squared. So if you use Pythagorean theorem, we could use 45, 45, 90. What else could we use to find that x? Yeah, 45 degrees here, right? Right? You do opposite over hypotenuse, right? Sine of 45 equals x over 58.
You just have 58, 58,
Why half? What's the half?
X plus X squared.
X squared plus x squared equals 58 squared. So 2x squared equals 58, or 58 squared, right? Big number. And you divide by 2. So I just did, I'm not going to do it, right? But we have 3 ways to approach this now, don't we? We've got a lot of stuff in our tool belt, okay? All right, so let me give you your problem set.